Today we'll explore how we can achieve operational excellence through intelligent automation in the iron making process. Traditional blast furnace face several persistent challenges that impact efficiency. First, there is a raw material variability which significantly affect the distribution of the burden inside the furnace, and consequently once the distribution gets changed, the utilization also getting affected, and overall we can say fuel rate, production productivity, everything gets affected. We also frequently encounter temperature fluctuation, and which leads to a loss of efficiency. Handling refractory wear remains always difficult and very challenging, often resulting in unpredictable maintenance event. Fundamentally, most operations rely on reactive model rather than a proactive model. So, artificial intelligence fundamentally transforms the blast furnace operation through two core capability, which as mentioned, there's the first is the real time processing. AI can analyze like thousand of sensors inputs, which is already uh, shown in the slide, enabling it to detect a complex pattern that human might miss. And second is the predictive intelligence. This capacity or we can say potential uh, of AI allows the system to forecast equipment failures within 72 to 168 hours before they occur. So it is a of course good time to see these time interval, and it is interesting too also, so that it can gives us a scope of our action plan. Now the result of AI implementation are already proven in the industry, notably in a case study involving many companies, and a few companies have already given the results, and based on their statistics only a overall scenario is presented. After implementing AI, they show a dramatic 50% reduction in equipment failure, which is a major coverage of AI. Maintenance costs were simultaneously reduced by 35%, which were quite obvious due to reduction in equipment failure. Overall, the operation achieved a significant 9% increase in uptime, and which is a good jump in order to combat the production and productivity of the shop floor and company as a whole. So AI brings critical precision to temperature control. Traditionally, temperature variance could be as wide as plus or minus 50 degrees Celsius, and which lead to a costly energy loss, and this interval is a big one as it is shown here. So yeah, we can say that it is a very costly affair when our variations are wider, and our aim is to bring it down the width of the variation, which will reflect in terms of benefit in optimizing energy consumption. However, AI optimized system often utilizing hybrid quantum machine learning can reduce these variance drastically to only plus or minus 7.6 degrees Celsius. So we can say that these improvement represent a good jump, and it represent at least 25% increase in accuracy. So operators benefit directly from the real-time pulverized coal injection or PCI recommendations, which prevent temperature overshooting also. Now, coming to our next slide, which is about a very important message. Here, AI enables a major shift from reactive maintenance to proactive maintenance. In the traditional reactive model, equipment fails, production stops, and then emergency repair is initiated. Conversely, the AI-driven proactive model works by predicting failure, allowing maintenance to be scheduled, resulting in zero downtime. This proactive approach has been shown to result in a 30 to 50% reduction in breakdown. So this gives a immense scope for improvement. Optimizing resources is another key benefit. AI analyzes raw materials uh, composition to predict the optimal coke rate required for the process. It also provides real-time burden monitoring, helping to reduce losses caused by maldistribution. And I think this has got a tremendous potential because once we have a distribution optimization which helps in achieving a better utilization or ETASIO, which will help in saving a lot of fuel for the blast furnace. For example, a case studied by Repeak reported a 3% productivity gain and reduced data CO variance up to huge extent. And its indirect benefit comes under a stable thermal control because once your utilization, gas utilization variance is squeezed or its fluctuation is narrowed, definitely thermal stability will be better. Now, one concrete application is the prediction of hot metal silicon content, and which is a very big agenda of discussion. AI is used to predict the silicon content in blast furnace casting. This capability allows operator to adjust the charge composition in real time. The outcome is 40% reduction in silicon variation, guaranteeing quality consistency in the final product. The transformation to intelligent operation is supported by three core pillars, and all these three core pillars one by one has already shown. The first pillar is the real time data integrity. This means every decision made is backed by live sensor data, eliminating guesswork. Now, as far the pillar 2 is concerned, it is about a predictive rather than a reactive sort of activity. Now, problems are identified early before they cascade into a major losses. And finally, the third pillar is the operators AI collaboration. Here, the AI recommend actions, and human operators validate and execute those decisions. Now, operators are essential to this process, and they have a several reason to embrace this technology. AI reduces physical strain through automated monitoring. It empowers operators by providing actionable recommendation, avoiding the confusion of black box decision. The system provides early warning, which are crucial for preventing dangerous emergency situation. Ultimately, this leads to improved shift-to-shift consistency and a better safety record, which is supposed to be a very important aspects for the production and productivity. The business case for the AI is strong, yielding significant return on investment. Companies typically see a 9% gain in uptime, translating directly into extra production capacity. So there is also a substantial cost reduction, which averaging around 12% across the maintenance and energy due to drop in the breakdowns. Implementing AI typically follows a structural roadmap, like in three phase. The roadmap has shown phase one, phase two, phase three, and we'll see the phase one, which is about phase one is taking month one to three, 1 to 3 month is phase one has been planned, focused on sensor and data collection primarily. This involves installing IoT sensors for parameters like temperature, pressure, and burden distribution. Similarly, if we talk about the phase 2 is having a span of 4 to 6 months and is about a model development. During this time, machine learning models are trained using both historical and real-time data. Now coming to the phase 3, which is about uh, mm, a story of month 7 to 9. So almost here um, 7 through 9 is live deployment. This phase includes dedicated operator training and a gradual rollout with a continuous validation. Now coming to the slide about one of the most important aspects regarding addressing operators concern. This is uh, about the job security, reliability, and training. We must also proactively address concern raised by operators regarding job security. AI is designed to augment, not replace, human workers. Operators gain powerful new tools. For reliability, the system incorporate fail-safes that allow for an automatic revert back to manual control if necessary. Finally, comprehensive training is provided through dedicated operator academics, a focus on the AI-enabled decision making also. Now, looking ahead, the future vision involves combining AI with a digital twin. This means creating a full digital replica of the blast furnace to allow for extensive scenario testing. This advanced integration will enable a real-time optimization during hydrogen-based direct reduced iron operations. Furthermore, carbon tracking will be integrated directly into AI recommendation to ensure compliance with ESG standards. The sources confirm that AI is not a future concept, it's achieving measurable result today. We have seen proven success from the companies which have discussed and shared their experiences, and through the application of hybrid quantum machine learning also the real uh, effect of this year 2025 is highlighted as the time of transition fully to intelligent blast furnace operation.